Hi, my name is Ameya, and this is our self-balancing bike project. So far, we've 3D printed our parts and we've put together parts of the frame. We also have other electronic parts like our motor and our servo, and we're currently in the process of testing our parts. And in the future, we hope to, fully put everything together and start coding it so that it actually balances itself, like this robot right here, which was a previous year's project, and it balances itself perfectly.
Hi, my name is Shri, and the theory behind what we're doing here is setting up a control loop that'll make sure that if we set some set point at which we want the robot to be in, so for the case of our bike, we want it to be perfectly vertical, we can take measurements at every single time where it's not at our ideal state and mark it as some error term. And using this equation over here that describes a PID loop, we can use the P proportional term and the integral term here and the derivative term here. The theory behind the proportional term is we want to measure basically how off we are and then determine in what direction we need to counteract to get back to our ideal point. The integral term basically describes how long we've been off of our set point, and then our derivative basically describes how fast we've been deviating from the error point, and that'll basically involve some quick thinking to go back to our set point. And that all culminates and is added together to determine our control action to get back to the set point. And we have these three unknown terms here that basically determine the proportionality constant, the integral constant, and the derivative constant. And when testing, we are determining what these values are supposed to be. And so there's a lot of fine-tuning process that goes into this, and when we're done, we get a full equation that we can use to actually balance the bike.